Hello, everyone, and welcome to today's webinar. My name is Matt Forrest. I'm over here at CARTO, and today we're talking about moving beyond Tableau and Power BI, or really any business intelligence tool, and how those tools aren't really suited for geospatial data. And we'll get into the very nitty gritty about why that is and some of the technical details, to talk about some of the limitations there and what you can do differently to kind of approach that. So that's our topic for today. As we get into this, just a few things that will come up. There is a chat should you have any questions. So if you have anything that you want to ask, feel free to use that chat feature and ask a question. We'll probably get to those at the end of the session, so we'll save some time to go over all of those. There'll also be a few polls. So if you if you see those pop up, please respond to them, and we'll share those. I think there's 2 during this time, and that's kind of it for today. We'll wait a minute or 2 here as people start to enter. But if you want to use the chat now, just to let me know where you're tuning in from, and maybe why you're here today, that'd be awesome, just to get a sense of what brought you here to learn about geospatial and business intelligence tools. So yeah, if you want to drop that in the chat, that'd be great. And we'll get started here in a few minutes. So just seeing a few people share the chat from Green Bay, Wisconsin. Glad to see that. I'm actually a big Packers fan. So awesome. Glad to see you here. Philadelphia, thanks for tuning in. Yeah, sad to share that. Yes, you will have the opportunity to rewatch this later. So after everything's wrapped up, we'll share a recording, so you can definitely check this out. Mesa, Arizona, welcome. Baltimore, New Hampshire, excited to see you here. UK, awesome to see everyone here. Wow, okay, they're really flooding in. Ithaca, Harris County, Toronto, Austria. Thanks for staying up late with us. Dallas, Texas, Durham. Awesome. Mexico. Yeah, glad to see everyone here. So now the chat's definitely working, which I was kind of waiting for, is to make sure everything's on. Jakarta, welcome. Portugal. Yeah, I'm glad to see everyone turning in here. St. Louis, awesome. So, okay, I think we've established that we're up and running. So let's go ahead and kick everything off today. Like I said, any questions, just those in the chat. We'll get to those at the end, and then keep an eye out for those polls as they pop in. So just a quick agenda for today. We're going to talk a little bit about BI tools and kind of what they do well and what they're really suited for from a technical perspective, and then where they maybe fall short. I don't have an agenda against BI tools. I think they do a lot of things really well, but as it relates to geospatial, we'll talk about the very specific limitations there. That's our next topic there. And then the next one is talking about the data connection. Why it's really critical to maintain a data connection for geospatial analytics, and why connecting to that data source is very imperative. Then the next piece is we'll talk about accelerating analytics and kind of how you can scale the analytical side. So that's answering your questions, anything from a spatial join up until more advanced workflows and things like that. We'll then talk about like kind of these scaling the insights and sharing that with more people. We'll talk through a few practical examples. I have 2 examples today. One with the, your kind of traditional big spatial data, which is the New York City bike trips data set. And another one talking about flooding, actually in the Midwest, which was just back in Minnesota a couple weeks ago, and got to see some of that firsthand, unfortunately. And then we'll talk about how we're bringing some different AI innovations in there. But I think we're going to send out one of the first polls here. So that should be popping up here momentarily. And just to get a sense of what tools you use, or BI tools you use to create maps. So if you use any of these, Tableau, Power BI, some other tool, or if you don't use a BI tool to create that today. I'm assuming people probably do, because that's why you're here today. So if you want to give that an answer, I'll jump into the next slide and we'll get the answers back from that. So for introduction's sake, my name is Matt, field CTO here at CARTO, based out of New York City. So I've been doing geospatial my whole career, and that's kind of the day in and day out of what I do. So that's me. And then let's jump in here to see where these BI tools fall short and where they do really well. And just to get a sense of kind of who's using what here, it looks like, the majority, about just almost half of everyone is using Power BI, so about 45%, and then pretty close split between Tableau or some other tool, and then a few folks that are using no BI tool for spatial analytics today. So thank you for that. That gives a good sense of framing this and letting us know where everyone's at today. So BI tools or business intelligence kind of came out of the space of being, data democratization within an organization. These organizations were collecting and have lots of data, and it was generally siloed into different locations, be that with specific teams or areas or data, locations and servers and things like that. And BI came to make that accessible to the organization so people could see these insights. And what BI does really well, there's a few things that I think it does really well. The first is here, which is basically this ability to filter, visualize, and what you would kind of think of as a cross filter. So as you see, I'm clicking on my right-hand side here between these different things, between auto and some of these different pieces. I'll see if I can get the GIF to go again here. It doesn't seem to go, but I think you saw it earlier where it's filtering and saying, okay, as I'm filtering down, every other chart here is contextually linked, and I can see those things change over time. So there's this visual inference that BI tools are really, really great at. My ability to grab some different data, slice it, filter it, and interact with it and get near immediate results. And we'll talk about why you get those near immediate results in a minute, but that's one thing that BI tools do really well. If you've ever interacted with one, it's very slick. You can get those answers quite quickly. The other thing that they do very well as well is do some very basic sort of data preparation or data cleaning, if you will. So in this case, what we're seeing here is that this data set coming from a specific set of data. I think this is on high school bowling scores, interestingly enough. It allows me to edit that. So if in the case, maybe you have you have a player name, say in one field, you have my name, Matt Forrest, and you want to split that, right? You can split that by a space and do some very basic data preparation and cleaning. So if your data wasn't totally perfect in the source, you can use a BI tool to clean that up and prepare it, maybe turn a string into a number, like you have, something stored like that. It shows up, you can turn it to a number, you can turn it to a currency, you could turn it to a percentage, all those things it does really well. Kind of your traditional set of like Excel type of functions, right? That works really well. And that's because of these things. So like we talked about the visualization options, that cross filtering between charts and tables and graphs. There's a million and one options to visualize your data in BI tools, which is, one of their very strong suits. The other one is those lightweight data transformations. I have some little cleaning things I need to clean up. There's other things that I think they do well. They connect to a wide range of different data sources. They connect to them. Some BI tools have some data prep capabilities, so like there's some transformation things. It depends on the tool that you're using. But for the most part, it makes data, it does what it was supposed to design to do, which is make data very accessible, interactive, and allows others to do some self-discovery of insights. And that's really what BI does amazingly well. And it's really transformed a lot of organizations. The primary reason that all that happens so quickly and effectively is what's known as in-memory data set analysis. So in memory, if you're not familiar with kind of the computing structure, data is generally stored in some sort of form, either a file or data storage database, something like that. Let's take an example of an Excel spreadsheet, right? I have an Excel spreadsheet. I have 10,000 rows of data, and I'm going to load that into the BI tool. Now, once that data is, basically what's happening is I'm connecting that data source, and all that data is moving into memory, or the storage, the internal application memory of the business intelligence tool. That's what's happening there. So that tool now stores all that data in memory. So when I click and filter, because it's stored on that memory disk, effectively the actual memory storage of the BI tool, which takes a part of that storage on your computer, it's super fast because it's already there. It's living there. It's alive. It's, in memory. It remembers it, if you want to think of it that way. So it's very effective at that. So it's taking data out of that data source, be it a database, data warehouse, whatever that is, putting it into memory, which allows you those lightning fast calculations. And that's where it really shines. So we'll remember that concept here in a little bit. Now, where this falls short, I would say, is the round trip communication with a data source, right? So let's say I have maybe a bigger data set, 100,000 rows in a database. And maybe I want to do some sort of filtering to join that to another data set and get those results back. That join would require some sort of operation at the database level. BI doesn't do so well there. Let's say if I click a filter or something and change a date range, all of a sudden, maybe my data set's millions of rows and I just wanted to select a date range. Now I want to filter down to a different date range. I have to go back to the data source and requery that. That's where BI kind of falls short, right? And there's a specific reason for that with geospatial data that we'll talk about in a minute as well. And it's that dynamic querying or that round trip communication with the data source. Remember, BI wants to load all that data in memory so it can do all those things fast that you saw in those GIFs earlier. When it doesn't do that, that's where things kind of stand to break. The other bit is the visualization of large data sets. And it's not that there's a very specific reason, it's good at visualizing data. As the data increases, the memory load is larger. It needs to process more data in memory. That just tends to break down. If you think of it you have so much space in your memory. I think some of the upward limitations of some of the BI tools are closer to 4 gigs or 3 gigs I've seen for Tableau. Power BIs or other, that's where that starts to deteriorate. That's where that starts to fall down, is that in-memory data set. And that's why the visualization break down. It's nothing wrong with the visualizations, just the data scale in memory. So now there's the geospatial gap in business intelligence, right? Now this is kind of a video that I put together that shows sort of a demo. This is in 2022 December. I'm loading in a data source here of some different locations. I believe this is US counties, and you can kind of see this is in real time at trying to load in, and here are my counties, right? It did a good job here of showing and filtering my data. But as I'm kind of selecting, you'll start to see where some performance kind of deteriorates or things like that. So as I'm moving, around, you can see that I'm not actually able to pan the map because there's too much data in memory. And keep in mind, this is only a data set of counties. There's some, I think 3,500, I forget the exact number. I think it's 3,650, I can't remember, of US counties. The problem with the counties, and if anyone's ever worked with geospatial data and simplifying them, is that there are a significant number of vertices within each of those areas. So while there's only so many rows, all the points that make up all of these different boundaries. Oh, see, sorry, these aren't counties. These are census block groups. So yeah, sorry, a little bit more data there. So those are closer to 200,000, I believe. So I tried to throw a little bit more out here. All of the points that make that up certainly scale it it makes it much larger. So any given census block group, and this is something I looked at in the actual data types, the smallest one is maybe a few, kilobytes or KB, if you're familiar with that. On the large scale, it's in the range of megabytes. So you have that individual row to store that geometry, and all the points that make up that geometry are into the megabytes. So all that data needs to get shoved in memory, and that geometry by nature is just a larger data type. It's just bigger, right? To store in memory a integer or a floating number like a decimal takes much less memory. And if you remember what we just talked about, the more memory consumed, that's when things start to deteriorate with the BI tools. And geospatial is just one of those areas. A point is one of the smaller geospatial types, the latitude and longitude, but still takes more memory to store that as a proper geometry, which is how that gets rendered here. And you just see this is me trying to interact with this map in very real time. It just starts to go slow, doesn't work. And that's where that starts to fall short. So it takes, just panning and zooming the map. You can see, this is a M2 Mac. So that's where that's going. And this is a comparable version in CARTO, being able to zoom and pan the map very quickly and effectively. And we'll talk about the differences between those, right? And that's really what you want to do. So here's me creating a map. This is from a few years ago. So there's been improvements since the internet, even at this time. You had 242,000 records. You can see here, I'm able to visualize, change, update, do all the things I want to do. So that's that scale. And this is just pure loading data, visualizing it, nothing else, nothing fancy beyond that. So just moving and viewing the map. So if I can click through here, this is generally the scale of geospatial data that's appropriate for a BI tool. You can load more points, and this is where there's some debates or edges on like how much data you can load in for a geospatial toolkit. It depends on the geometry type specifically. But if you're looking at this in terms of states, you can see these are highly simplified boundaries, right? You can see there's malaligned edges here in Nebraska and along the Washington-Idaho border, oversimplified using as few points as possible to make it as fast as possible. Once again, decreasing that memory load. For points, it's the same thing. There's a little less overhead because let's say, if you're thinking about this as a data set, each of these geometries has, let's say 30, 40, 50 points in them. That number of points is what you would take to store, then to load those points in. So we're getting very down to the data level, but it all talks about that. The more data in memory, slower performs. More data in memory, slow performs. That's the issue with BI tools. It's not like a bad thing. It's just the way they're set up. Just kind of the way it is. Now, there's a lot of ways that these tools try to get around that limit. So here's the concept of data binning, where you're aggregating those points. And this is something that everyone does. If you think of grids or hexagons, H3 cells, quad bins, it's a very common strategy to load that in and bin your data here. So this is something that you can do, but it's trying to overcome that limit of too much data in memory. It's trying to take that at a base level, aggregate it up so the visualization will run much faster, which is fair. Here's where you see where this starts to break down. So these are two questions from user groups. On the left is Tableau, on the right is Power BI. And so the first one says that I have a database of 3 million records, tried to create the field calculation to make point. What's the upward limit? And I don't have a hard upper limit of how many points you can load in. Obviously, this person wasn't able to do it. This is in 2020. And if you see on the right here from Power BI, this was their super user answer, not currently possible to show millions of locations on a map. So there's an upper limit of like in the millions range, or even up to 1 million that we don't exactly know for each of these different tools. And that's points. Points also make up polygons. So you can see as you construct polygons, you can create fewer polygons or lines or things like that. Those points are just the building blocks of lines and polygons. So that gives you a sense of how much that is. Once again, the more data memory, the slower the tools are going to go. So why is geospatial tough? What makes it unique? What makes it different? As I mentioned, the geometry is a larger data type. It builds iteratively as you add more. If you add another digit to an integer or something like that, it's very effective for computers to store that. These are base data types, or another letter to a string or anything like that. The geometry, on the other hand, is a much larger data type. As you build it out, it's kind of like a linear scale. It grows and grows and grows and things like that. And then the transformations themselves are never simple. There's the joins look a lot different. If I'm joining on two strings, I just need to calculate equality. Let's say I'm joining on a data set of NBA players. Is Cleveland match Cleveland? Does Milwaukee match Milwaukee? Does the Knicks match the Knicks? Easier to equate that. Calculating a spatial join, I actually have to do a number of calculations. So if you're wanting to do a point and polygon calculation, does this point fall in the polygon? There's a few steps. First, you're creating a bounding box around the polygon just to see, okay, can I eliminate all the points that don't fall in that bounding box? Great, I did that. That's 4 points, 1, 2, 3, 4. Here's the thing that falls within it. Now you have to calculate that point amongst all the other points in the polygon. It's a much different type of join. So just computationally a different join. And then there's the visualization requires specific techniques, right? As you saw that video, what's happening is they're trying to load that entire data set into memory. They're able to hoist it into memory, but once you pan and zoom, that becomes slower. So on one view, you might get to see it, but once you try to interact with the map, it starts to break down. That's where techniques like map tiling come in, and then you need to scale that more effectively. So that's the other piece, is that you need specific visualization techniques around map tiling. If you're not familiar with map tiles, it's basically the building blocks of a map that say, there's different levels. Given those different levels of zoom, you show the appropriate data for that level, and that's effectively makes all web mapping technology go. If you think of it that way, you show less at the global level because I don't need to see every single thing. I don't need to see where every Starbucks location is if I'm looking at a view of the globe. But if I'm at a street level view, in a metro area, I want to see where those little points of interest are and things like that. So it's showing the most appropriate data at the zoom level, which very much differs from a normal chart or table or anything like that. You don't have that level of spatial view as it goes up and down. Okay, so the next is around the data connection. This is the other piece that I mentioned, is that how does this severance of data connection work? And we'll talk very specifically about that, because here's how BI tools work, right? On your left, you have, let's say, 10,000 rows, which is the original example that I gave you. You have maybe a data set on a server, you have a database connection, you have a data table, whatever that is. When you load that into, your BI tool here, you're effectively, let me see if I can get like a little pointer so I can kind of show this. Let's see, here we go. So as you're loading this in here, you're taking this data out of here and moving it into this. It's moving the data out and into memory, right? You're transferring that data. As you look forward here, and I guess I have to turn this off now. So maybe this wasn't my best idea here. You're looking at moving, how do we move 100,000 rows over here? Can it handle it? Yes. As you saw, we got up to 200 some thousand, but it might be a little slower, right? 10,000 is more than 100,000. That's pretty much it, right? That's all we're talking about there. What about a million? That gets even to larger scales. And you saw where that, at least the spatial data, that starts to break down, and what about 3 million, right? We know that the more and more you add in, the more you're rolling to memory, the more it's going to cause problems, or, be slower, right? And that's the whole concept with BI tools. The only solution, and it really doesn't matter what you do down here. If you're prepping the data differently, you might be able to do a few things to optimize it, but it really doesn't matter, because it's taking that data as is, moving it into memory, right? The only things you could do is maybe pre-aggregate your data. But what if you want to filter on something before you aggregate? A good example of this is what we'll look at is actually the city bike data. So the city bike data, we'll talk about in a minute, but has that concept of an individual trip that has a start point and end point, a date, a bike type, and the stations it ended and started at. So it has very specific data in that. Now you could aggregate that to see where are all the trips in these grid cells. But what if I want to filter for a date range? That data is loaded into memory and it's pre-aggregated. I lose that because of that aggregation. I'm averaging or grouping or doing something like that. I'm losing it. The only solutions I've ever seen to fix this problem over here is throwing GPUs and higher processing tools at the BI tool, which is not scalable. GPUs are, most things on your computer use what are known as CPUs, or computer processing units. I think it's maybe computational. I can't remember the exact word, but CPUs. And that powers all the things that you do on your computer. Everything from moving your mouse to interacting with Excel to any number of things. GPUs are the graphics processing unit that process the things you see, right? And if you're, what I do know about GPUs is they're definitely, if you're a video gamer, that's something that's important to you, because you want very good graphic processing to see your video games. I don't play video games at all, so that's about as far as my knowledge as it goes there. But they're very powerful, somewhere in the thousands or 10 to 1,000 times more powerful than a CPU. That also makes them more expensive. And GPUs are commonly used in machine learning workflows, generative AI workflows, because of that power. So they're very powerful, but they are not cheap, right? If you're using this in the cloud, it's quite costly. So it's a very much a, it's a very, it's a very quick fix. It's a Band-Aid to fix the problem at the score. And it's going to cost you. And some organizations have done this, and that's fine. But it's not the best practice. So talking about how we do things at CARTO, that's where things start to differ a little bit in terms of scaling that. So CARTO basically has this direct connection to your database or data warehouse. In this case, there's 5 different tools that we support here. More coming as we are progressing, but there's 5 that we have, and you're connecting into these data warehouses or databases that have spatial capabilities. That's why we chose them. Of course, we're a geospatial company, so that's why that makes sense. But most of BI tools connect to these things anyways, too. You'll see those connections there. The difference is in a few areas. One is that we maintain a direct connection, right? When I do something in CARTO, I can call down to that database and data warehouse, process it, and get the results back. So there's that complete feedback loop. I'm not just taking data out, loading into memory, and hoping that whatever is in memory can work there. That's just not the way that our system works, because we know the limitations of geospatial data. The other component here is that we're picking and choosing these that have specific spatial capabilities at scale. So to see what that looks like, these are much simplified graph here, but imagine these are the data warehouses. So these are the 5 that you see up here, but just represented by this nice chart of or image of a database or a data warehouse. When you do something, you ask it for data, right? I'm getting a result back. I'm asking a question. I'm querying it. Whatever I'm doing, I need some data. And I'm typing that into CARTO. I'm performing some operation. CARTO then calls down to the data warehouse and asks it for the data. Hey, can you send me some data, right? Here's the data I need. Here's that, and it's structured in the language that SQL or spatial SQL that the data warehouse understands. The data warehouse processes that data inefficiently. These are really powerful tools for processing that at scale. They're really, really good at this. That's what they are made to do, is process a massive amounts of data, analytical queries at scale. That's exactly what they do. So the data warehouse takes that question we've asked and processes it efficiently. And then what the nice part about what CARTO is that it returns it in the best possible format. Now, with the analytics toolbox that embeds within the data warehouse, that allows us to return map tiles. And without your touching it or doing anything, it returns the best possible format. Sometimes that's dynamic tiling. Sometimes we don't need the tiling, so we don't need to do that extra processing. So we skip that and just get you the data as fast as possible. Sometimes there's just raw data, and we'll send you a lat long over the wire, over the wire, but over the internet. It's the same type of thing. But we'll send you it in the most efficient method for what you've asked. And you don't have to think about that. It's hands off. BI tools just try to load it, cram it all into memory once again, and it's maybe not efficient. So that's what we try to handle. Is we know that geospatial data requires those different, components. But let's imagine a situation where the user still wants to ask more questions. Say I have another question like that date range question I talked about. Hey, I'm really just curious about this date range. Now, if you've pre-aggregated your data, like in that Tableau example where you saw the bins, sadly, you cannot do that, right? It's pre-aggregated. You lose that date feature because let's say you're averaging the number of trips or counting the number of trips per bin. You lose all the individual rows there that have that date timestamp. Now with CARTO, I can still ask that question. I can still say, hey, go grab this chunk of data and show it to me. Ask that question, and then you get the data back. So you ask the question again, returns the best format. And you get that complete cycle and feedback loop that allows you to do that at scale. And within this, what's important to note is we're not transferring data. We're not taking data out of a data warehouse and loading into memory. We're providing things like map tiles that are just used for the representation of the data. CARTO never stores any data. There's no data in memory. There's nothing like that, and that's kind of the difference between a BI tool where you have to, kind of store all that data in memory and cleanse it or clear it, anything like that. So if you've hit those limits, you'll know what I'm talking about, but that's kind of the pieces there. So let's talk a little bit more about, let's see here. Just wanted to make sure we have, okay, cool. Just checking on time. Talking about accelerating analytics and how we scale the analytical side, because this is just taking data. We're talking about, getting data, retrieving it, pulling back in. What about the actual analytical questions you want to answer? Things like spatial joins all the way up until more advanced machine learning workflows. That's something that you just can't. You can do some of those things in the BI tools, but they're very limited, right? You saw a very basic data prep in there. You can do, sorry, is this dramatic image? You can do some things like splitting your strings or adjusting data or very simple stuff like that. What if I want to answer a very complex spatial question? Even just simple spatial join, I know there's some basic tools do that in Tableau, but they're incredibly slow because once again, you're trying to process all that in memory. Here's a question I want to answer, and this is an image from that flooding in the Midwest that I talked about. I was back in visiting my folks with my family, and they live near the Mississippi River, and it's like the highest I've ever seen it. There was just so much water compared to last year, where it was like a drought, but this year is just massive flooding. And this is a dam that burst near Mankato, Minnesota, just because of the high waters between rain, snow, all those different things. So, there's just this massive amount of flooding. The multiple cities in Iowa were flooded. So it's just this, really devastating flooding that was taking place. A question here you might want to ask is, okay, where are the floods? Like where's the high water, right? Very common question you want to answer. And there's tools to do this. This is the National Water Prediction Service, which is provided by the National Oceanic and Atmospheric Association, or better known as NOAA here in the US, that provides this data. And as you can see here, there's all these dots on the map, which are stream gauges or river gauges that measure the water height around the United States. So there's tens of thousands of them. I think it's maybe 30,000 in total. And what they do is that they measure the current and observed height in the past. So this over here, if you see on the left side of this dotted line, is that's observed, and then they forecast that out, given where they think the water height's going to go. And you can get a very clear view of, okay, at this exact point where this gauge is, here's the water height, and here's where we think it's going to go in the future. So as you see on this map, there's tens of thousands or 10,000 points. Let's say 10,000 points for argument's sake. And you can see that the red ones have higher water. This was taken yesterday, just to get the data up to date. The yellow ones have, or orange has a little bit higher water, and then yellow and so forth until it's basically, where it needs to be, or, a normal height. You can see that there's still this flooding down here along near Iowa into Missouri. This is going to be the Mississippi River. Missouri River's over here, and some other rivers across the Midwest up here. I think it's the Fox River and things like that. So, the flooding looked a lot different. It was much more concentrated up in this area before that. So if we just wanted to show this data and put on a map, you could do this in Tableau and Power BI. You could get the data from here and pull it into your BI tool and show that. That's fine. Usually what you want to know is something else. I want to know where I think areas are likely to have flooding, right? And if you think about that question, is I need to know the height of the water in that area, plus the elevation around it, and specifically the drainage that goes from that. And drainage is basically saying, like, what's the nearest place where that water is going to run off to? So if I have 10 extra feet of water, which areas don't have the drainage that can support that? That's the question we're trying to answer. And it's basic math from there. Problem with the drainage data is that it's stored in what's known as raster format. BI tools cannot support raster format. At least I haven't seen it. So if someone knows different, you can correct me. But that's a raster format because it's data derived from satellites. So we have this data set that supports that. And this is what the analytical side looked like. This is a fairly complex multi-phase step analysis using our tool workflows here to actually create that flood view. Now, to walk through exactly what I'm doing, I'm taking that river gauge data and I'm storing it every hour. This workflow is scheduled to run. I don't have to do anything. It's hands off, set it and forget it. I'm ready to go. And I'm pulling that gauge data in every hour, and I pull it in for the current day, and then from a range of 1 to 5 day predictions. There's a 24-hour prediction, there's a 48-hour, 72-hour, so on and so forth, up to 5 days into the future that they predict. From there, I take all of the rivers in my study area. In this case, that's the Midwest. And I am creating a buffer around that and a grid of points. So I create, a 5-mile buffer, and I create a sample grid of points. From there, I predict the likely height of the water in that area using spatial interpolation. Because I have a sample set of points, I can interpolate that using some different techniques. It's called spatial interpolation. BI tools can't even get close to that. So this is, we're already like a few steps beyond what they're capable of handling. They might be able to create the buffer. I don't know if they'll be able to create those sample set of points. So and they can't load this other data set, which is up here. So I turn those points into a spatial index to have a more efficient join. And then I uploaded this data set called hand or height above normal drainage. I learned about this data set when I was talking to someone at a conference. I was like, I would really love to solve this problem. They're like, oh, you need to check out the hand data set. I'm like, okay. And that's what I did. So I grabbed that data set, I pulled it in, and I ingested the rasters. And then we end up with something like this, which tells us at that snapshot into the future, this is a 96-hour prediction window. Where do we think there's likelihood for flooding? And you can see some of those areas that I was talking about in Minnesota, down through the Mississippi River, and into here where we think there's that height that's significant in terms of the total area that's going to be flooded. So that's what we're looking at here, is these are areas that are likely or could have some flooding. And the darker that is, the stronger that prediction might be. So it gives us a very clear view of okay, this could BI tool visualize this amount of data? Of course it could. Of course it could visualize it, these different grids. Could it do anything like this? No way. So the first bit is like, how much spatial analytics do you need to do? how much work do you have to get the data just to prep it and cram it into memory? Do you want to do all this in that tool, or do you want to have something that can automate it? That's like question one you want to answer. BI tools have very, very, very rudimentary, spatial processing capabilities. So just keep that in mind. So we end up with something like this, tells us a very clear picture of the flood. And the best part is I'm hands off here. I'm running this every hour. I don't have to do anything. The second somebody accesses it, they're getting the most up-to-date data. So it's really, I don't have a lot to do on my end to carry that forward. Now, what if we're talking about visualization? Okay, I need to visualize a large amount of data. There's a blog post that I put out just to say, like, how much data can you actually visualize with CARTO? And long story short, it's a lot. But like, those are interesting. I can visualize a ton of points. How can I actually get better insights from my data? That's what I want to answer. And this is an amazing blog post written by my colleagues Helen and Anna about SQL parameters. Now, SQL is the language that processes or that all those data warehouses use. And SQL parameters allow us to directly interact with those data sets back and forth. Now, remember, if you said like the load into memory issue, I have a city bike data set that has tens of millions of trips. There's been millions and millions of people have taken city bikes all over the city here in New York City. I can aggregate that and show how many trips are taken by each station. That's pretty easy. There's hundreds of stations. There's not many. So could BI tool load that in? Yes. What if I want to see just the trips that took place that left one neighborhood and went to another, or between a specific date range? Or, what about the around July 4th? You have to go back to that database and query it. And if you remember, I can't do that with BI because everything's loaded in memory. So that's where that starts to break down. Now, this is the map that they produced, and it's very nice. And I think much better explaining this. So we'll actually go into and show that as an example. So what I can do here is, you can see I basically have a start neighborhood or a set of neighborhoods defined, which is the West Village, and this Hudson Yards, Chelsea, Flatiron, Union Square. So basically these areas up here that are in blue, and where they end up is in Lower East Side or Chinatown in red. And I'm looking at this date range, which is going to be from 2018 January, the entire month. So let's imagine that I want to see for the first 5 days of the year where that went to. What's going to happen is that's going to trigger those SQL parameters, and it's calling back to the data warehouse. It's going to query it and return it in the best format here. The data is going to update, and you can see a few of those points dropped off the map. But let's say I just care about going from Hudson Yards into Lower East Side. It's going to do the same thing, call back to that core data, and then show me just those results, right? You can see it's going to get rid of all those other points that I don't need and show them there. And if I click on this, I can see the results at that station. There were 2 trips there, 4 trips here, and you can get a sense of what those are from the, who was taking those trips and things like that. So that gives you a very clear picture of what that looks like. So you can get very specific with your insights in terms of data moving back and forth. And then here's where they ended up. So you can see a lot of trips left from this area here. This is going to be around Union Square, and ended up here in, this looks like in the sort of Alphabet City, Lower East Side area. So that's where most of those went to. And if I could change this at any time. So if let's say I really wanted to look at how many went to the Upper East Side and ended up there and went to the Lower East Side between that same date range. It's a very specific date range. And then I can see that it's going to filter, move my dates up here, update my layers, and go there. That's the thing that you don't get with BI tools, is that ability to communicate back and forth. So I just, wanted to like over highlight that and really, focus in on that. And that's the extra piece that you get there. So to kind of bring that forward, there's this sentiment in spatial that there's this spatial is special concept. Spatial is, geospatial is a special data type, sure, right? I think that as we move forward, we'll start to see that geospatial is becoming simple. And I think generative AI and some of these AI pieces are a very good way to unlock that. It's not foolproof, it's not perfect, but I think it's a great way to do that and go from there. So what we're bringing and our goal as anyone working with geospatial is to get that into more people's hands. If you think of that data democratization that I talked about from BI, the more we can do that with geospatial, the better. And I think this is a great way to access that. Geospatial data, there's some people that are very familiar or comfortable interacting with dashboards like that, and maybe some that aren't, but they know what they want to find, right? So they can express that through a text-based question, right? And that's what we're bringing forward with this CARTO AI agents, which is a feature we're working on and bringing out and testing in beta phases right now. So I just wanted to highlight this because I think it's applicable to our conversation today. What this allows you to do is you can build an agent that leverages these large language models from OpenAI and Google and others, and connect them in, and then provide context from your map itself, from your dashboard. And what this allows you to do is that it can be used by the viewer of the map to actually ask these questions. These are sample questions. You can actually provide these yourself, right? So if you said, show me all the bike trips, between these two neighborhoods, in the days surrounding New Year's Eve, you could do that, right? You can have the specific date ranges. You can pre-prep this, or the person can ask them themselves. Now, what this requires you to do is you can create this in a simple AI agent in the Builder UI. It needs two pieces of information. It needs some information from you as a user, right? That's the creator of the map, that you tell it, you give it the context. Here's what this data is. Here's what you're looking at. Here's some of the questions you might answer. And you, as the creator of the map, have that unique context that you provide to it. So you're giving it a context to work with. It also has an automatic input that's passed in from the map itself. So things that provides in are like, the layers. It knows what the layer is and the data types in there. It knows the widgets that you've created to filter the map. And it knows that SQL parameters that, hey, someone's probably going to want to filter on date or neighborhood. So it provides you that at a greater detail too. Now the agent has that map context. You give it some starting prompts, and then you give some introduction data to the user. So this is, you provide context, questions, and then how you can help the user. And then these are all the automatic inputs, right? So there's a description about the map. I can read that and tell you what that is. I know that here's population, here's the ranges of population I can filter on, here's the layers, and here's what I'm styling. We take all this information that you've already put into it and bring that into it and go from there. So it's very easy to kind of bring that in since you've already done that work. And then here's some of the things that you can do. You can ask it to interpret the map and provide descriptions about the actual visuals in the map. It'll look at it, read the map, and describe it to you. Zoom into specific locations. You can create, filters on different areas. Say, just show me these neighborhoods, or you can turn layers on and off, or you can, do all these different things that allow you to answer those questions. So it allows you to start a conversation, right? You can actually start to quote unquote talk to the map if you want to think of it that way. But what I really actually love about this is that, if someone's just approaching this map and says, I don't even know what I'm looking at, how do I filter that? If this is their first time you're interacting with that, we should be pushing towards a way to make that simple, make spatial simple and democratize it for more people, which is where BI started and where I think it does a good job across a lot of different things, except in geospatial, as we've covered today. I believe this gives us a much better way to get this into more people's hands, allow you to have that conversational question. So if you say here, I want to look at the number of shipments delivered in this area, it's going to filter the map, and it's telling you step by step what's taking place. I'm going to analyze the map. I'm taking over now. I'm going to filter it. Here's where I'm filtering it. I'm filtering deliveries. It's going to tell you exactly what it's doing. So it's not some black box thing, and then you just end up with a map. I'm telling you the steps that I'm taking. So it's transparent, which I think is really important. That's where I love what we've done with that and creating that as a space. You can also get those insights. So once it's done, it says out of a total of the 116,000 here, it's 72,000 were made in a 20-minute drive time from this operations. 61% of them were made from here, and it zooms into the map. So it zooms into the map, shows you what you need to show, does the filters, creates the context visually, and then gives you a text output. I mean, I like that I think, and shows you the steps that's taking place there. That's what I really love about that. I think it's just a really amazing piece. There's more coming on this, but I think just as a context of like the democratization, how do we do that and go from there? That's something that I think is really important. So with that, I have a few questions that came in. I'm going to answer those. If you have more questions, feel free to drop those into the Q&A or the chat. I got both up here, so I'm going to kind of go through as I got them in. So one question was about using QGIS or ArcGIS. What made someone use a BI tool? Number of different things that could have been an organizational choice. Like sometimes people don't have the licenses to those different tools. I think in a lot of cases is that a lot of organizations outside of your GIS or geospatial teams will have a BI tool in place. So that's what people are used to using, and the licenses that are in place. So if you can move it into those tools and don't have to have everyone have an ArcGIS or QGIS or another tool installed, especially for, that specific geospatial use case, that's probably why that took place. That said, you're going to be subject to the limitations there. And even in QGIS or ArcGIS, there's some limitations within that, right? There's a certain amount of data scale. It's a desktop tool, right? There's different things. So there's another component there. But if I was betting, I would bet on that as probably the reason why that would be there. Is there an ability to complement traditional BI tools with CARTO, for example, a BI dashboard that also leverages CARTO's mapping capability? Good question. And yes, so one piece, another feature, a component that we've been working on is basically what's known as parameters in the URL. Now, in that builder map, there's those same contexts around the widgets, the layers, things like that. We can read input from the BI tools and then map those into the CARTO dashboard. So should you say, I'm just looking at this area, we can detect that, embed that into the build BI dashboard, excuse me, and then be able to detect those and then update the map as you update those different things. So it's kind of this cross sync. You would create the map in CARTO. It's not like a CARTO embedded in the BI tool, but you basically have some level of cross collaboration there and to communicate between the tools. We've also seen this work really great with Salesforce. If you have like, I want to embed in CARTO map and filter down with Salesforce, another great way to use that, but separate from today's conversation. Let's see here. Why do BI data tools load all data into memory? From what I talked about, that was basically to have that very, very fast, snappy visualization. Once it's in memory, it's sitting there ready to use. It's at front of mind, right? So if you're thinking about like data retrieval as like your brain operation, like I have a memory from 5 years ago, I have to probably think about it or remember what that is. In memory means at the front of the tip of your brain, ready to discuss. That's right out there. So that's where that comes from, is like, hey, it's very tip of your tongue type of thing. And it makes all those visualizations we showed at the very beginning very snappy, fast, quick, and that's what they do really well, right? They no qualms about that. I don't have an issue there, but that's what they do well. It's just that, when you get the geospatial data and the volumes there, as well as loading that amount of data into memory, and that's where things start to break down. Why are data volume limits? What are the data volume limits for BI tools? The data volume limits for BI tools are effectively hard to describe. From what I've researched, I believe that Tableau desktop has about a 4 GB limit. I don't know if that's a limit of all data or just some data. So I'm not entirely sure about that. That's one. And then it varies in terms of rows and storage, right? Like you'll see some people that will reach a limit at 3 million rows, and some that'll reach a limit at much lower volumes because of the total data storage volume. That also makes a difference in terms of total number of columns. The more columns you add, the data storage goes up, or the disk space. The more rows you add, the disk space goes up, and the data in those rows, the larger those are, disk space goes up. So it's kind of this matrix effect of like, you have, let's say you have 4 GB to work with, and that's the true limit. I'm not entirely sure, so I'd have to check that out. And of course, it depends on your computer and all these other things, but just for argument's sake, 4 GB. And I have 3 million rows that fits in, 3 million rows with 5 columns that fits into that space of 4 GB. Now, if I added double the amount of columns, I'd probably only get 500,000 rows. This is pure argument's sake. This is not, perfect math or anything like that, but you get the idea. If the geometries increase in size, then maybe I only get 200,000 rows or 100,000. That's just from that picture. So that's why there's these. It's a nebulous amount because it very much is dependent on the data, sort of number of rows, number of columns, and then within each cell, the data storage there. Okay, a few other questions here. I'm trying to go between both. Can we talk? Okay. Takes a lot of time to query big spatial data sets. How do you minimize execution time without pre-aggregating? We basically let the data warehouses do their thing. They're very powerful, and we let them do that. Now we make optimization. You can make more optimizations on the table, and CARTO helps you do some of that to cluster or partition and do some of those database things that you may or may not want to do, but it helps you scale that really effectively. So it does some of that at scale for you, but it's basically your data backend is very, very effective. BI tools connect to BigQuery, Snowflake, all the same ones we do, but they try to take that data out of memory and bring it in. We have that consistent feedback loop because that's what geospatial requires. Could you clarify about how to integrate different shapefiles, rasters into a single analysis, the specific format? Our import API which is not the API, but there's a drag and drop feature. I should call it that. Our import tool set allows you to read files from your desktop or remote files. If it's a remote file, and you have it syncing, either in a workflow ideally, and you say, hey, I need it to run every hour, we'll go and look at that data set. And if there's a material change, we'll do a difference between the two, we'll just pull in the new data and pull that over. There's a number of vector formats we support for raster data. We're working on having a drag and drop feature ready for that. But there's a raster loader that you can use to actually load that in via Python or command line or things like that. So there's a few extra steps with raster data, but it should be ready to just load in like a drag and drop, same thing, URL format if you want to do it that way. So in terms of adjusting the data, I mean, if you have a CSV, if you have a shapefile, GeoJSON, GeoParquet, KML, KMZ, the list goes on, it's ready to go. So can you talk about the strengths and weaknesses, the various platforms you support for the geospatial CARTO use case? I'm not sure if this is about the different data connections we have. They're all very strong. I don't think it's a lot of the decision comes down to, if you're in a large organization, than what someone's decided there. The difference between the two are pretty nebulous once you're kind of, I don't even think you're splitting hairs. They're all very good at what they do. So it's a lot of it's around, what the technical or IT teams have mandated. So there's not a lot of like splitting hairs there. Can you read raster data hosted in a Postgres database? We don't read it and visualize it. If you vectorize it, we could read it there if you turn it into like a vector format. But if you write a query and you want to enrich points or something like that, yeah, we can read that in just fine. So it's you have to do some of the vectorization pieces there, at least from Postgres. If you want to do the pure raster loader, that we have a specific format we use to get really into the weeds. We use the cloud optimized GeoTIFF tiling schema that supports more efficient joins on quad bins and things like that. If you want to just reach out, we can go through that in detail. But if you have the raster data loaded in, you connect it there and you write the SQL to enrich your data, you're fine. So you can do that there too. Does Power BI work with all spatial data formats, especially NetCDF? I don't think they work with NetCDF. NetCDF usually is going to be a raster format. I don't think BI tools work with rasters at all. If someone wants to correct me there and I'm wrong, that please do. But they generally work with, and they may work with some of the core ones, like a shapefile, definitely CSV. So they work with some of those core types, but it's not perfect. So you'd have to go into the individual docs and see what they do work with. Can I share any tutorials on using and analyzing visual time series data? Yes, please go to academy.carto.com. That's where all our tutorials are hosted. There's a ton there that talk about the time series components. So please check that out. Can you help us to transform geospatial information? Is there experience in a better tool, CARTO, than, for the mapping? I have a question. In your experience, is the better tool CARTO than Power? So is it better to use CARTO than Power BI for geographic data? I'm going to say yes. I think that was kind of the case I was trying to lay out. I hope my evidence presented that. But yes, I do believe that that's the better choice for geographic data once you reach a certain scale. If you just need to throw a couple points on a map, you use Power BI. There's nothing wrong with that. Once you get into volume, once you get into the data volume, into the panning and zooming that I just showed you, or geospatial analytics, then you need something like CARTO to be in there. You need a tool to do that. So, and when you talk about cloud data warehouses, those pieces, CARTO's the top choice for that. In CARTO Builder, can you slice and dice entities in layer X based on selections in layer Y like other BI tools? Yeah, that's where you saw some of that spatial, the SQL parameters and things like that. If I filter a specific location, that's where that's coming in. More importantly, the AI tools will allow you to do that. So if you type, I just want to filter by this component, you can do that. Like it's not even going to be needed to like you need to hook those things up. Your AI agent will handle that for you. So yes, and yes, soon with generative AI is the question there. I think I answered the question about the raster data. Sorry, I'm going between the questions. Could you clarify how you integrate different shapefiles rasters into a signal analysis, a specific format? I answered the question on formats in terms of how you integrate them into a single analysis. CARTO workflows is the way you do that. So once again, academy.carto.com. There's some examples there. If you have more questions, reach out to us and we can kind of show you those in greater detail. But that's the place you want to go to check out how you do raster analysis, how you do those different things like that. I think I got everything. If there's any more questions, ask them now. Those are all great questions. Thank you everyone for being super active and discussing all these different pieces. I really appreciate it. I hope this was really valuable to you. Any other questions you have, feel free to reach out to us. You can reach out on the website. If you want to shoot us a question somewhere else, let us know. If you want to reach out to learn a little bit more CARTO, go to the website. We'll send this over as a recording afterwards so you can rewatch any of these pieces as well. Once again, thank you for your time. Thanks for spending a little bit of your afternoon, morning, evening, night, depending on where you are with us today. Hope you enjoy the rest of the day and see you soon.